Welcome to Wicked Wednesday, everyone. Thank you for showing up for our lesson today, and thank you for showing up for your learning. Here we are with this topic, adding and subtracting rationals. Perhaps you could see this as the culmination of factoring and the culmination of fractions up until this point in your math careers. It's going to take both topics and put them together. So we want to remember that when we have something like 3/2 plus 4/5, that we want to create a lowest common denominator here. Here, we notice 2 and 5, they don't share any factors. If I did do that thing that Ashani doesn't like, you would see that this would be 2 times 1, and the other one would be 5 times 1. The only thing they share is 1. That's not really sharing anything, because all numbers share 1. Well, integers anyway. So there you just have a lowest common denominator of what? What would be your lowest common denominator? 10. It'll just be 2 times 5. So you can always do that to create a common denominator. You can always just multiply these numbers by each other. That's what I was saying. We could use 240 here as a common denominator. But it's going to be really awkward if this stuff looks like that. You're going to create quartics and powers of x to the 5 by doing that. We want to be a little more efficient. So over here, when I have x plus 1, and that over here in the x minus 4, what would be my lowest common denominator there? Can anyone see it? I'll give you a hint. We do the same thing we did over here. The lowest common x plus 1 and x minus 4. What's the lowest common denominator that I could have in these fractions? It's going to be x plus 1 multiplied by x minus 4. That's the only way to create a lowest common denominator there. Multiply the two denominators together. All right. So, sorry? Where? For the lowest common denominator here? X plus 1 multiplied by x minus 4. I have to multiply both denominators by each other to get a lowest common denominator there. That will be the lowest common denominator for those fractions for all values of x, except x is -1 and x is 4. Those would be excluded from the domain. We don't invite them to the party. They're not allowed in the kingdom. Okay, so our flow chart for these types of problems is that we want to...
Do you FOIL it then?
Yeah, then you would FOIL to create a trinomial. Yeah, this will be a quadratic as a lowest common denominator.
And then you would have to like bring that up and then do like 8 times the trinomial.
Let's do this question. Let's do it. This is a good question. So let's do that and find out what that weird fraction-y question will give us. Let's go, everybody. So here, to answer a question like this, I am going to, first of all, copy out my question. 8 over x plus 1 minus 5 over x minus 4. And then I multiply top and bottom by the missing factor. So I'm going to put that in brackets so that I remember. And then I'm going to multiply this by x plus 1 on the bottom. And I have to multiply by x plus 1 on the top. And then over here, I'm going to do a similar thing, but I'm going to multiply by x minus 4 on the bottom. And I'm going to multiply by x minus 4 on the top. Okay? Now, let's do it. So this is, I got an equal sign there. Bring it over, equals x minus 4 times 8 gives me 8x minus 32 all over x minus 4 or x minus 1. So let's do our... Oh, right. Yeah. It's in my bag. Let's do our FOIL. So here I want to make sure I get all these terms. So I might draw in these arrows because FOIL is going to show up whenever I'm multiplying binomial times a binomial. So that will give me x squared plus x minus 4x. So that would be minus 3x. Plus 1 minus 4 is minus 3. And then minus 4 times 1 is minus 4. That's actually a common denominator for the other side as well, because I'm going to be doing the same trinomial, so the same binomial times a binomial over there. So it's going to be the same denominator. So I can write the whole thing over the same denominator. And now I'm going to have minus, and I'm going to put this in brackets. 5 times x is 5x. And then that's plus 5. So that's in brackets. I'm going to subtract all that from that. So then, because I have this written over a common denominator, I can now say this is equal to 8x minus 5x is 3x, negative 32 minus plus 5, so that's negative 37, all over x squared minus 3x minus 4. X is not equal to negative 1 or 4. And I got those restrictions from here, from the denominator. Both of these values make this trinomial equal to 0. Let's take a look. Negative 1 squared is 1, minus 3 times negative 1 is plus 3, so that's 1 plus 3 is 4, minus 4 is 0. So can't have x is equal to negative 1. Why is that? Well, because of this factor. And the same would be true if I test the number 4. So that's done final answer. And there's nothing I can do here to simplify these. Yep. Okay. Yep. Mac?
Sorry, I just like writing it down so eight times, wouldn't it be 8 times negative 5x? How is that 3x?
8 times negative 5x?
Like down at the bottom. That's the answer. 3x.
Where?
Subtract 37.
3x subtract 37, yeah. Because I had, let's collect my like terms, 8x minus 5x and negative 32 minus 5. This I could also distribute in if I want to remove the brackets, and I would have 8x minus 5x and negative 32 minus 5. Avery?
Since the 5 over x minus 4, like multiplied by x plus 1, since that's also the same, it gives the same denominator as the other one. Would you put a squared denominator, or would you just leave it?
Oh, so when I have something like, let's do this question here, and we'll see. 3 over 2. This is a variation of take a very complex idea and look at it in a simpler context. So when I have something like this, I say this is equal to 15 over 10 plus, and then this one, 8 over 10. Right? I just multiplied this top and bottom by 2 and this top and bottom by 5 to create that common denominator. If I want, I can write another step, which is 15 plus 8 over the common denominator. But the denominator just stays there. I don't add denominator to denominator. I don't multiply denominator by denominator. It's now a common denominator. It's saying the pizza has been cut into the same number of slices in the first case and the second case. So now add your slices together. Over here, we were subtracting, and so this was not multiplication here, this was subtraction. And that's why I had 8x subtract 5x. So the only difference between addition and subtraction is this would be addition or this would be subtraction here, and that comes in down here as well. Okay, so let's take a look at some of the problems that we are going to be looking at with these types of topics. If I want to simplify something like this, well, my first step is factor all the numerators and denominators, then find the lowest common denominator. So let's do those couple steps here. So our first step is going to be factor. So there's only one thing that's going to factor in there. What is it? Yeah, and what does that factor into, Marcus?
X minus 4.
Yeah, x squared minus 4. So this is a difference of squares. And here's a hint. It's going to share this factor.
2.
Yeah, so we have x plus 2 multiplied by x minus 2. So here's a difference of squares, x squared minus 4. That factors into x plus the square root and x minus the square root of that number. And so there's our difference of squares. And now we want to create a common denominator. We're looking at this and we see they both share the factor x plus 2, but this one has a factor x minus 2 on the bottom. We need to add that factor over here. So let's go ahead and do that. We're going to multiply top and bottom by x minus 2 on this side to create that factor. Now we have this as a common factor. Now the next step is to state all the restrictions on the denominator. So we want to go through and find the values that x is not allowed to be. So what are those? Yeah, so let's put that in a little box over here. X is not equal to -2 and 2. Good. Now, we're going to actually FOIL this and expand it. That way we can add the x plus 3 over there. So let's write another line. And it's going to be equal to, the denominator here is x plus 2 multiplied by x minus 2. That's the common denominator. And I just write that all on one line. X plus 3 is still x plus 3. And then I'm going to add the results of x plus 1 multiplied by x minus 2. So let's find that out. X times x is x squared. X times -2 is -2x. 1 times x is 1x. So I have negative x, -1x. And 1 times -2 is -2. So now I have x plus 3 plus x squared minus x minus 2. So let's bring that down to another line and collect our like terms. We will have x squared, x minus x is just 0, and then 3 minus 2 is plus 1. X squared plus 1 all over x plus 2. Oops. X plus 2 times x minus 2. And then, oh yeah, sure. So I just collected like terms here. This made that x disappear. Plus 3 minus 2 is just plus 1. Now I look, can I still simplify anything here? And I see, no, I can't simplify anything there. So that's finished. Try another one? Of course, let's try another one. So here we have another one. Simplify this rational expression. Well, don't mind if I do. First step is to factor the numerators and denominators. So I'm going to do that. I'm going to say this is equal to 5x minus 1. That doesn't simplify. 5x minus 1. All over x squared minus 3x plus 2. What's that? -1 and -2. Oh, sorry, you're right. Wait. Yeah, that's right. Yeah. Sorry. And then plus, this is 3 over 2x minus 4. Does 2x minus 4 factor? What does it factor into? I common factor it. I see that 2 is common to both, and I factor out the 2. So 2x minus 4 factors into 2 multiplied by x minus 2. Now I'm taking a look. This one has a factor 2 and x minus 2 on the bottom. This one has a factor x minus 2 and then x minus 1 on the bottom. So what factors do I need to add to both sides here? X minus 2 is already common to both.
So you need to put 2 here.
I need to have 2 on this side. And then what do I need on this side? X minus 1, yeah. So let's add our factors here. So I'm going to add x minus 1 as a factor here by multiplying this fraction top and bottom. And then I'm going to multiply this fraction top and bottom by 2. 2 over 2. Yeah. And now you'll notice common denominator. 2 times x minus 2 times x minus 1. And then 2 times x minus 2 times x minus 1. There we go. Hi, how are you doing? Good. So let's do that. So now let's come down to another line. We're going to have this is equal to, putting some brackets in here helps me avoid mistakes. So 2 times 5x is 10x. 2 times -1 is -2. And then I'm going to add the results of this multiplication here. 3 times x is 3x. And 3 times -1 is -3. All over 2 times x minus 2 times x minus 1.
Do you expand that?
This?
Yeah.
I'm going to leave it factored for now because then I can clearly see my restrictions on x And in case this adds to something cheeky that's going to cancel one of these factors, I don't have to refactor and find that again. So I would leave it factored. So now I see that 10x minus 2 gives me 13x minus 7. 13x minus 7 doesn't factor.
Wait, not 7.
Minus 5, yeah. 13x minus 5 also doesn't factor. 13x minus 5 all over all this stuff. So now let's go ahead and state our restrictions. 2 times x minus 2 times x minus 1. Okay, and x is not equal to, and we can find our restrictions there. We'll notice that those are the only things that show up on the bottom. So what is x not equal to?
1 and 2.
1 and 2. There we go. Good. Good, good.
What's the answer for the x plus 3? That one?
Here?
The
This one?
yeah.
Oh.
What answer did you get though?
I got x squared plus 1 over x plus 2 times x minus 2. I have a weird doohickey there. That's not very nice looking. Let me rewrite it. X squared plus 1 over x plus 2 multiplied by x minus 2.
So is that also x squared minus 4?
That's x squared minus 4 on the bottom, yeah. Now, we have one more example to do together, and then it's time to get to work on some practice problems. So this one, I'm looking like I might run out of space. Oh my goodness. I like to write a little big. So let me put this in. All right. So now, let's take a look at this one. First step, factor the bottom. So go ahead and factor this on your own. There's only numerators to factor. So work away, try and solve this problem. I am going to pause the video, and then we'll resume to take a look at your solutions. All right, thank you for attempting that question on your own or solving that question on your own. And here's my solution. So the first thing that I notice is that the bottoms are trinomials, and they both factor as trinomials. The first one, y squared plus 5y plus 6, factors into y plus 2 multiplied by y plus 3. I haven't changed the numerator yet. I just factored the bottom. I just showed you the bottom in a new way. And this one factors into y plus 3, y minus 4. I notice then that they both share this factor y plus 3, but that this one lacks the factor y plus 2, and this one lacks the factor y minus 4. So I have to multiply this factor in on this one, and multiply this factor in on that one to create my common denominator. Next step is to do just that. So when I do y minus 4 times 4, I get 4y minus 16. And then when I do 5 times y plus 2, I get 5y plus 10. And I remember I'm going to be subtracting that from this. So notice that I put that in brackets. Another thing you could do here is you could bracket this and say this is negative 5y times negative y plus 2, and then add it. But I prefer to do my subtraction and do this multiplication, put it in brackets, and subtract the whole bracket. Okay. So now I have 4y minus 16 minus 5y minus 10. On the top, my denominator is a common denominator, so I can write both terms over top of that denominator. And then when I simplify that, it's 4y minus 5y is negative y, and negative 16 minus 10 is negative 26. All over this cookie denominator.
Do we have to simplify it or no?
There?
No, the bottom, like the denominator.
The denominator you could.
Like,
Yep.
Is that what you would want us to do in the test?
No, I don't need to see you do that.
Okay.
It's not bad practice, but I mean, it's not great practice either. It's like kind of like this is negative y and negative 26. And then I FOIL the first one, so that's y squared plus 5y plus 6. And then I'm going to multiply that by y minus 4. And then so I do that, and so that gives me this is equal to y cubed. And then I get a y squared term here. Y squared times minus 4 is minus 4y. And then this gives me plus 4, so this is plus y squared. And then for my linear y terms, I get this one times that was negative 4 plus 6, so plus 2y. And then I get here minus 24. This is negative y of minus 26. So if you want to expand it, this is what you would get as your final answer. You don't have to expand the denominator. to be honest, I understand this better than I understand this. So I would leave it that way. Just leave it this way. Yep.
Yeah, where did 2 and 3 come from?
Okay, so Diego's wondering where these came from, and Marcus is wondering where these came from. So let's go back to the question. Yeah. Okay. So first I noticed that a y squared plus 5y plus 6 factors into y plus 2 times y plus 3. I look for two numbers that multiply to 6 and add to 5, and I find them as 2 and 3. Okay, so that's where those came from. These ones, y plus 3, y minus 4, came from factoring this one. Plus 3 and minus 4 multiply to negative 12 and add to negative 1. And then I look, this is my denominator here, this is my denominator here. I want to create a common denominator by adding in the missing factors to either denominator. So I add this factor to this denominator by multiplying top and bottom by that. It's the same thing that I did up here. I multiply top and bottom by the missing factor. I multiply top and bottom by the missing factor. 25 over 60 is the same thing as 5 over 12. It's just we've cut the pizza into more slices, but it's the same amount of pizza. Same thing that 4 over y squared plus 5y plus 6 is the same thing as 4y minus 16 over y plus 2 multiplied by y plus 3 multiplied by y minus 4. This is the same as this. I just multiplied by 1 to change that. And then this one, I multiply it by a different cheeky 1 to change it. And I'm smiling because I know that this is the point where I don't really have an intuitive understanding of the math anymore. There, I can think about slices of pizza, and I can relate that to things I understand. And to understand this, I need to relate this to something I already understand and just trust the method. Okay? Sure. So this is what I would have as a final answer here.